Hi, I'm following along with Paul McCorders Raspberry Pi Pico W lessons. We're on number 80, and he's teaching us how to use timers. And this has been probably one of the most active postings of homework I've seen for quite a while on the Pico W. And a lot of creative juices going between the people that are following along with Paul, and a lot of good code examples of different ways of doing it and everything. People have made multiple videos. Charlotte's made 3 videos. A couple people have made two videos on it. So I thought I'd jump on the bandwagon and make a second one. I've already got the one that I did over here. Um, so our job was to do an asynchronous blink with the using timers to create an asynchronous blink, and I came up with a solution that I thought was pretty good. And I did get someone named Peter down here in the comments said that I was using one-shot timers. And with one-shot timers, you can get at a little bit of an expanded, an unknown expansion of your time period, by maybe a millisecond or two per loop or whatever. And that's you know, to me, that wasn't a problem at all. Usually if you're blinking LEDs, you're not worried about it. But he mentions that, sometimes you really do want it to stay at 1 millisecond over time. So if you're blinking after an hour, you want your number of blinks to be whatever comes up to an hour. You don't want it to be, take an hour and 5 minutes or an hour and 10 seconds or whatever to um, blink that many times or whatever. So I thought about it. I said, well, maybe there's a different way of doing it that I, come up with. I'm always looking for creative solutions myself. So let's get to the code. So, whoops, let me get myself out of the way. I don't need to see my big face. All right. So this was the one that I come up with that I think is uh, fairly elegant, that uses a periodic timer. So we're importing uh, pin and timer. That's the only two things we need to import. I got 3 LED objects up there, but I'm only actually doing one in this program using the R LED. So what I'm doing is I'm setting up a what I call a red timer on, and we're setting it up as a periodic timer. And this period here is the total period of the uh, on and off time together. And we are just doing, and then we're using our Lambda, like I showed in the last one, where we can do one line of code in our Lambda thing, whether it's sending your code off to another function or whether you're just doing like an internal thing. And on this one, I'm just turning the LED on, and we're doing it that, just turning the LED on. And then I have this next one, and this is actually, it's on 2 lines, but it's one line of code. It was just too long, so I just cut it and brought it down here. So what we're doing is we have the red timer off. Okay, so to get the uh, differentiation between the on time and the off time, uh, you have to stagger your timer. So I guess I should say that in the end, we're going to have 2 periodic timers, and we're going to have the same period on both of them. But we need to get a, a stagger to the off time so that we turn it off, so the whole period is 1,000. So we're going to stagger it by this 300 milliseconds. And then after that, we're going to just call the periodic timer every 1,000 milliseconds to turn it back off. So they're going to be staggered. So you actually are using 2 timers in this for each one. but um, we were using two timers the way I did it as well for each one, so it didn't really matter. So um, anyhow, to get the staggering, you're starting off with the RT off timer as a one-shot timer. And like I said, it's a period of 300 milliseconds. And then it's going to do the lambda T. And instead of turning an LED on or off here, it's actually calling another timer. Like I said, this Lambda can only call one line of code, and this is actually one line of code. You're reinitializing when the one shot finishes, you're reinitializing that same timer as a periodic timer and with a full period. So it's going to start at, the 300 and then it's going to go to full period. So at 1300, uh, milliseconds, it's going to come and turn it off again. And at 2300, it's going to come and turn it off again. So all we needed was the on time and off time. So, and then the lambda T when it becomes a periodic is just going to turn the LED off. It's not going to call another timer like we did. So this one shot timer is just giving us the separation or the offset to of the on and off. So it's a little more confusing because you got to put your full time, your whole period here and your whole period here, and this is just your on time. So it works well, and it's just a couple lines of code. So if people that are pretty good at reading code are going to probably figure out that there's one problem with this is that a periodic timer doesn't start until the period ends. So with this one, you're going to have 1,000 milliseconds before or whatever your total time is before your blink is going to start. And I thought, yeah, well, that's not too bad, I guess. But I'm sure I get people saying, "No, that's not good." So you can't really, that didn't really solve the problem. So we had that. So anyhow, I thought, well, I could try changing it in this, but it's going to add a few lines of code to it and everything. And so I just decided to leave this one the way it was, and I was going to copy and paste and make three of these. And I said, you know it would be real easy just to incorporate this type of thing into a class and just use the class, and that way you can make as many timers as you wanted to. So that's what I ended up doing. I created this class, or it's the file is called T blink, T underscore blink, and the class is just TB for timer blink. So that's our class. So anyhow, I figured why not do the creating the LED object and everything right in the class, so we don't have to do anything in the main program. We don't even have to import the pin in the timer. We're doing it here. So we got that. So for each one, we're going to bring in, of course, you're going to name it, and then you're going to just give the number of the pin, the on time and the off time. So just three arguments is what you need to do that. So the first line is going to create a LED, a self.LED object, and you're setting up with the lead pin number here, and we're just making it a pin out. So that creates our LED. So you noticed on the other ones that we had a full time. This one we don't have the total period time on here. So we have an on time and an off time. So I just do the math in here when I create the period, the P object here, self.P object. And so this is where we start to change our code just a little bit to take care of that, getting it to start right away. So the first thing I do is I turn the LED on. That gets us going. And then I start my periodic timer to get the um, we're doing the lambda here. It's going to go for the whatever this plus this, it's going to go that period, and then it's going to turn itself back on again. But of course, we need to turn it off in between there sometime. And we started on here, and this one's going to wait a while, and then it's going to turn it back on. So the timer off one is where we have this. And because I needed to turn the LED off at the end of our one shot, I couldn't put it all in a lambda code up here. I actually had to create this T off function down here so that I could put two lines of code in there. So we're just calling that uh, uh, this function here for it, and we're carrying ourselves through this so that no matter how many LEDs we got, we know which one we're working with. And we're turning that LED off, and then we're setting up the timer again. We're initializing the timer, the same off timer from a one shot to a periodic. And again, we're doing the um, uh, period, which is the total of the two. But now we're offset by whatever the one shot is, and the one shot is just the on time, and then we're calling back the uh, just a lambda of self dot lead dot off. We turned it on up here, and we're turning it off down here, and so uh, and this here might be a little confusing. I probably should have had a better function name than T off. It looks awful lot like lead off here, but T off. And so we're doing that. And 15 lines of code, we have a class that we can handle. So let's go up and see. I got a sample program here. And like I said, the name of the class is T underscore blink. So from T underscore blink, we're importing the class TB. And so then all you have to do, like I say, we're not importing machine or anything like that because it's all taken care of in our library. So we're just creating a R, a Y, and a B LED object. And we just need to import the pin number, the on time and the off time, pin number, on time, off time, and so forth. So for each one. And that's all you need for each LED you want to do. You can just put in, you know, one short line of code, and it'll take care of it. So I got all my LEDs off. Let me see if I can put it here on the thing. Oh, can't really see them. It's a red, blue, and yellow LED. And I'm going to go ahead and try to see everything at once here. And we're going to go ahead and, oh, looks like I got something running already. I got to stop. And let's go ahead and run that. And you can see that they start off right away. So they started right away. The blue one's got the really quick 100 on, 100 off. The yellow's got really slow second on, second off. And the red one's in between there. So you can just see that they're all doing their thing. And I let this run overnight just to make sure there wasn't any problems like I had with my first one. I was pretty sure it wouldn't be any collisions or anything. By the way, I did check, and it was a collision that it was trying to initialize that T3 timer um, at the same time or something, and it was a collision on it. I I found a nice little program. I'm not going to talk about it today, but it's like 6 or 7 lines of code where you can see how much memory you're using on your Pico over time. And uh, these codes don't use much memory at all. I mean, I think it's like 5% of the memory is all, these codes are using. So that's kind of cool. I didn't know how much a timer might take up more than you think, with all the what's going on in behind the scenes. But evidently, it's fairly efficient on use. So I would think that you could have quite a few timers going on. So anyhow, that's my second homework for Paul's class, lesson 80. This is Tuesday, so he's going to have 81 and he's going to show how he solved it. But I tell you the truth, after 80 lessons, his class is kind of just uh, we're taking what he shows us and taking it all to another level. Anyhow, thanks for watching. Have a great day, everybody.